Well, welcome everybody. Thank you so much for coming and joining us today. I'm Maggie Powell. I work in AWS Security Assurance, and I support the energy sector. Really hope you're having a good week gathering new ideas and new inspiration here at reInvent. The energy sector is facing dynamic times. Many factors are driving transformation towards a clean energy future. According to the UN, the energy sector is the source of approximately three-quarters of the greenhouse gas emissions today. And it holds the key to averting the worst effects of climate change. Today, joining me is Gabe Micah from San Diego Gas and Electric. Woohoo! And in this session, we're going to talk a bit about the challenges of energy transformation and share some innovative ideas on carbon reductions and talk about some methods to achieve those goals. Decarbonization is driving a build-out of cleaner energy resources and greater electrification of society as a whole, meaning that the energy sector is responsible for both its own reductions and for powering the reductions of industries across society. Electrification of cars, trucks, trains, even airplanes is increasing the demand for electricity overall. Estimates say that electricity demand is expected to increase by 25 to 30% by 2030. Take electric vehicles alone. The sale of electric vehicles worldwide doubled in 2021 over the numbers in 2020 to a record 6.6 million vehicles sold. That's quite a change considering that in 2012, 120,000 vehicles were sold worldwide. Less than 10 years later, more than that are sold each week. Concurrently, the rise of newer, cleaner energy sources, such as wind, solar, batteries, and fuel cells, are decentralizing the electric grid landscape. Cleaner and renewable resources are expected to overtake fossil fuels by 2030. And electric generation, is moving closer to the source of consumption. And when you consider the role of elements like electric vehicles, it's creating a two-way flow of both electrons and of data. These changes are driving an explosion of data streams across end-to-end, from consumers down to grid-scale resources. Digital technologies are enabling customers to gather and analyze data end-to-end. Consumers are able to use smart grid technologies to manage their own, to see and manage their own energy consumption, all the way down the energy value chain to field devices and in control rooms that are using IoT and edge computing to help with activities such as maintenance and outage responses. These changes, let me continue with that. The digitalization is also about how to handle all these data volumes to create value for your operations and for cleaner considerations. AWS is a valuable part of enabling this transformation. Customers leverage the lower carbon footprint of AWS data centers when compared to their enterprise data centers. They're also expanding their compute capacity and analytics capabilities to create value from that growing data volume. And AWS is working with customers to innovate around solutions to meet reduction targets. Reinvention is underway across the industry. The energy sector is rising to the climate change challenge. And here's a few examples I'd like to share. In India, Greenco is using IoT and serverless for their wind power monitoring and their grid system management. It's maximizing their integration of renewable resources into their grid. In Australia and New Zealand, Vector uses cloud-enabled IoT, machine learning, and big data analytics to facilitate a more efficient grid management and to integrate renewable resources into the grid, all in service of creating more affordable, reliable, clean energy options for their customers. And Engie has built a centralized data lake to bring disparate data together, including data from legacy systems, together to benefit really their global operations, as well as help their customers achieve their own sustainability efforts. These are just a few examples. We know, though, that the task isn't always simple and it isn't always easy. While it is about technology, it certainly is not just about technology. It's about innovation, and it's about a culture of innovation and creating that environment to enable innovation. And to do so at the pace we have before us. Net zero by 2050 is an ambitious goal, and it's quickly approaching. Energy and utility providers have the incentive to accelerate their innovation. And to achieve that is going to require adopting some innovative approaches, methods, and mechanisms to help support that innovation. One of the AWS leadership principles is bias for action, which states speed matters for business. Many decisions and actions are reversible and don't require extensive study. We value calculated risk-taking. Yet many leaders view all decisions as irreversible. We would call that a one-way door decision. But if every decision is a one-way door, the process is quite slow. Meetings are lengthy and laborious, and it's really hard to capture momentum and build upon it. One tool to help unstick that traditional decision-making approach is to recognize that many decisions are reversible. We would consider them two-way door decisions. And to create a nimble, innovative environment requires that leaders make a lot of two-way door decisions. Understanding this distinction can create an environment of experimentation. You can build into the work plan rollback steps to help manage that innovation and expectation. You can create failure options that have a very low cost in case you had to roll it back. And you can also create an environment, if you do have to roll it back, there's lessons to be learned. Because remember, rolling back is not a failure, it's information. As leaders, we're taught that to make a decision, you should have about 70% of the information you wish you had. If you're waiting to have 90%, you're probably moving too slowly. So I shared a couple of examples of the energy transformation that's underway, and I've offered the two-way door approach as a method to help support your innovative endeavors. But next, it's time to jump into the deep dive into the details of how innovative and transformative initiatives can be implemented by setting out a roadmap for emissions reductions while proving business value and delivering social good. And to talk about cutting carbon where it matters most, please help me welcome Gabe Micah, Director of Digital Innovation and Customer Experience at San Diego Gas and Electric.
Great job. Thank you, Maggie. All right, we're here to talk about cutting carbon where it matters most, which is really about bringing our community data front and center into our decision-making process. I'm going to talk about why we innovate, why is it important to innovate in the energy and utility space today, how we innovate through our Learn, Prove, Scale framework, as well as what we're innovating. What are we building? What are we architecting? What's the value from those investments? And before jumping in, a little bit about the company. San Diego Gas and Electric began in 1881 as San Diego Gas Company, serving 3,000 customers. Shortly thereafter, began to deliver electric service and grew to what it is today, serving 3.7 million customers across the San Diego and Southern Orange counties. And the other part of my role is supporting and driving digital innovation for the Southern California Gas Company, whose service territory runs from Central California all the way down to the Mexican border, serving 21.8 million consumers. It's a big number, tremendous amount of infrastructure, and a tremendous amount of opportunity to drive real value, especially in the topics we're going to talk about today, around maximizing our efforts around decarbonization and keeping the communities front and center in our decision-making process. Over the last 140, 150 years that these companies have been in business, a lot has changed. So I always like to start out with the industry fundamentals are changing. Increased climate risks, prolonged drought in the West are continuing to fuel not only the sheer number, but the intensity of the wildfires up and down the West Coast. That in turn is driving the industry to decarbonize. And it's bringing sustainability front and center in the corporate agenda, which is a really important thing. Rising customer expectations, rising investor expectations. Both customers and investors are expecting utilities to play a more critical role to enable the energy transition. We'll talk a little bit about that. Cybersecurity risks, they're continuing to come at us as dynamic as they ever have been. And all the while, business change has continued to accelerate. And these factors are not only transforming the industry, but they're really demanding that energy companies and utility companies transform right alongside it, and to the extent possible, stay out in front of that change. Digitalization is the key culprit in accelerating that rate of business change. We call this the tale of two companies. Companies that are leaning into digital are increasing their enterprise agility. They have the ability to respond to changing market conditions faster than they ever have before. And those companies that aren't are fading away. They're being left behind. And what we mean by digital is it can mean taking a manual process and digitizing it, but what we really mean is extracting every single ounce of business value out of our existing investments. And to further that, it's about keeping our eyes on the horizon to understand emerging technologies and understanding if and when we should be investing in those technologies to drive long-term business value from an organizational perspective. And the largest opportunity we have to drive that value is really through cloud. We are at a cloud conference, so I'm saying that and I mean it. The major cloud service providers invest over $100 billion in research and development every single year. And they're furthering things like artificial intelligence, machine learning, natural language processing. We're going to talk a little bit about that. So projects that may have taken us 3 or 4 years to complete in the past, maybe we can complete those same projects today in 3 or 4 months because we have the ability to consume that capability on demand through a service in the cloud. It's a total game changer. And this is our innovation framework. Learn, prove, scale. Very straightforward. The hardest problem was just getting started and increasing the frequency at which we utilize this framework. Because we know if we only test out 1 or 2 emerging technologies every single year, we're highly unlikely to find something that's gonna drive some real material value or to transform the organization. So we try to test out 10 or 15 emerging technologies every single year with the hopes that 1 or 2 pan out and fundamentally transform how we operate as an organization. The learn step is all about rapidly learning, 6 to 8 weeks total. We wanna get in, we wanna get out, we wanna understand, does the technology actually solve the business problem? How does it fit within our architecture? How does it fit within our culture, especially when we're talking about artificial intelligence? Proof step, very straightforward business case. What's the cost to implement this technology? And what's the value? And does that pencil out? Value in this context is gonna be about maximizing our decarbonization efforts and increasing equity and driving societal value where we can. And once we decide an investment in an emerging technology and we intend to scale it, it's really about staying laser focused on extracting every single ounce of business value out of that investment. Because we know that if we are not laser focused and hunting for business value, we are unlikely to find it. So it's always important to keep top of mind. This is a summary of our innovation portfolio, what we've been testing out over the past 3 or 4 years, what we're testing out now, as well as what we're gonna be testing in the next couple years to come. We started out 4 years ago testing out automation capabilities, robotic process automation, one of our earliest investments. We've been driving a tremendous amount of value from an organizational perspective in that space, testing out natural language processing from a customer perspective, understanding how natural language processing, virtual agents, chatbots can help increase customer satisfaction and drive down the cost to serve. A couple of the major investments that have come out of this framework, one is around computer vision, which we refer to as intelligent image processing. And that's where we built close to 100 machine learning models to automatically detect both assets and damages from imagery. So as we're bringing in millions of images from the field, from drones and vehicles and phones, we have the ability to automatically detect what's on our poles so we can reconcile our asset information, as well as understanding, are there any damages on those poles? And more specifically, are there any damages on those poles that may lead to wildfire so we can remediate those immediately? And as we look to the future, it's really about field safety, wearables, the connected worker, testing out IoT in the field, and more importantly, communications in the field, making sure that we can bring back all of that rich contextual data back into AWS so we can run advanced analytics workloads on it. So bringing communities into focus, this is where we start the conversation about the Community Impact Platform. The Community Impact Platform really starts with the acknowledgement that we are all committed to driving equity where we can. Because we know that the same communities, the communities of concern, disadvantaged communities, are the ones that are continuously being impacted by both the causes and the effects of climate change. So as a company, we took a step back and tried to understand what's our impact on our communities that we do have the privilege to serve. But more importantly, what can we do? How can we take a proactive stance? How can we take the investments and the decisions that are in our control to drive greater societal value, to make sure we're doing right in our neighborhoods? Because ultimately what we're trying to do is explain to our customers why we make the decisions that we make, to our regulators why we should be investing in infrastructure modernization projects in the field to increase reliability for everyone. And more importantly, explain to ourselves that we're making the right decisions with our data for every single one of our communities. And decision making is all about creating the right context. So with the Community Impact Platform, we're bringing in all of our internal data, fleet data, facilities data, infrastructure data, any operational data we can, and we're bringing that together with externally available information, census tract information, socioeconomic status, air quality, transportation data. And for every single use case that we bring through this Community Impact Platform, we're trying to achieve these 3 objectives. The first one is visualizing the data, where we can start to infer some insights. What you're seeing on the screen here is just that. The heat map is our fleet telematics data, where red represents the intensity of our emissions. And that dark area is what California deems as the top 25% of our communities of concern, also referred to as disadvantaged communities. The second piece, after we visualize the data, it's about understanding the intersection between those two different data sets. How does our fleet operations impact these communities? And ultimately, what we're trying to get to is optimization modeling, which is the ability to prescribe or recommend an action or an investment to drive the most amount of value from an organizational perspective. And again, that's about maximizing our decarbonization efforts as we're electrifying our fleet while increasing air quality. And to start with the problem statement, the business problem around fleet decarbonization, our fleet team came to us a couple years ago as they were starting to prioritize the electrification of our vehicles, and they asked us to help with the priority. So we came up with this how might we statement together, and it reads, how might we design our fleet transition? So how do we move from internal combustion engine vehicles to zero emission vehicles or electric vehicles to maximize our positive impact on underserved communities? And three main objectives there. We're trying to electrify our fleet. We're trying to roll out the right EV charging infrastructure to support the electrification of our fleet, as well as keeping the communities front and center in that decision-making process, which we're going to go into right now. And the capability we used to answer that question is digital twin. And digital twin is a virtual representation, which could be of a physical asset or an object. I like to take it a step further and talk about a representation of our business or our operations, where we're building it out to simulate or run different scenarios to understand the outcomes of our business decisions. So over time, we can optimize our decision-making process to maximize the value with the things that are in our control. An example that I like to use is mapping software that we all utilize on our phones and our vehicles. And what does mapping software do? It takes all of the factors that we care about. Am I in a carpool? Do I like to pay for tolls? Right? City streets, highways, traffic. And it takes all those factors and it optimizes my path from point A to point B to maximize value. And value in mapping software is about getting from point A to point B in the least amount of time. Right? That's what we care about in that scenario. When we talk about building a digital twin for our business, we're bringing in all that internal data, all that external data, building out the right context to maximize the value for the things that we care about and the factors that we care about. And it all starts with data. A lot of topics about data this conference. It's been a lot of fun. I know I'm not alone by saying that data can be our greatest asset as a company. It can be, but all too often we can't access the data. We don't trust the data. There's quality issues with the data. So over a year ago, our data and analytics team started to put together this new architecture referred to as the data mesh with the concept of data producers and data consumers. On the bottom left, we have our external data. This is our community-based data where we've established the data pipelines to produce socioeconomic census tract data into the data mesh so any team on the right-hand side can consume that data, assuming that they have the right access. In parallel, our fleet team is producing all of that telematics data into the mesh so any team on the right-hand side can consume that data, assuming that they have the right access to it. So as a community impact platform team, we look through the service or the data catalog and we understand that we need these data sets, we pull it down, and we build out our optimization models. Easier said than done, but that's essentially the flow. And our mantra here is integrate once, consume indefinitely, and that is very important. Integrate once, consume it 1,000,000 times, integrate it once, and solve the business problem at the speed that you need to, which is extremely important when we're talking about innovation proof of concepts that only last 6 to 8 weeks. We could spend the entire time trying to find the data. Step one, data visualization. Specifically, geospatial data visualization. What you're seeing here on the screen is our fleet telematics data, and telematics is a sensor that gets plugged into every single one of our fleet vehicles or our service vehicles that helps us understand where that vehicle is moving across the service territory, how fast is it moving, how hard is it braking, how quickly is it accelerating, is it at idle? And we also know the make and model of the vehicle, the year of the model, so we can actually estimate and calculate the emissions. So as the vehicle is moving throughout the service territory, we understand exactly how much it's emitting every single step of the way. And that's what you're seeing here on the screen is the individual emissions data points. For reference, this is the Interstate 594 interchange just east of downtown San Diego. And that red signifies the intensity of our emissions, which are main transportation corridors in the area. But what you also see is all of the data points that all of our other vehicles are emitting during their normal course of work as they're making service calls on all those surface roads, which is pretty cool to see. Again, we could start to infer some insights from this, but it really doesn't get us to real insights or real decisions. And before moving in to the next step, a little bit about the data visualization architecture. It all starts with data mesh, which we already talked about, and we're consuming that fleet telematics data from or through the data catalog and through lake formation, and that's coming into the raw data S3 bucket. The biggest problem we had when we first started doing this was we were trying to render 80 million data points through a web browser, which was taking 10 minutes, and that was not going to cut it. So in comes Tippecanoe and SageMaker partnership there. And what Tippecanoe does is it takes those 80 million data points and it creates a map vector tile, which is essentially allowing us to see what those 80 million data points looks like, but without all the computation that's required as it's being consumed through the front end. So Tippecanoe creates these map vector tiles. It pushes that data as a document into the process data S3 bucket, which is then able to be queried through the API gateway, through the Lambda, through Athena, and all the way back out to the front end. Step 2, simple analytics. This is the intersection between internally available data and externally available data. The question we're trying to ask of our data at this point is, what is our impact? Which communities are we emitting more so than others? And what you'll see again is this is another transportation corridor, not one, but actually two, where they're merging right in the middle of this community, which is probably one of the main drivers why this is identified as a disadvantaged community in our city. And you could debate that our emissions, our 1,500 vehicles driving around the service territory, is a very small percentage of the total emissions in this specific community, but we still want to understand our impact. So if we can make a decision, we want to make decisions based off of data, which is telling us exactly what our impact is. A little bit about the architecture. The main piece to note here is we're utilizing EventBridge, and what EventBridge is in the keynote this morning. What EventBridge allows us to do is it allows us to understand when there's changes in the data. So for example, our fleet telematics should be refreshed every single day, every single night, but that externally available data from the state might only come in a few times a year. And regardless of the data source, we want to understand when it's changed so we can run our analysis. We don't need to run this analysis every single day or every single 15 minutes or every single hour if the data hasn't changed. So we want to run fresh data and come up with those insights. So as, again, somebody is trying to consume those insights through the front end, through the API gateway, Lambda, Athena, all of that data has been triggered from EventBridge, transformed, pushed into that process data S3 bucket, and it's available to be rendered all the way back out to the front end. And the third most important piece to this process in the community impact platform is where we try to get to for every single use case, and that's the optimization modeling. And the question we're trying to ask of the data here is, if we could only electrify one vehicle, which one would it be to maximize our value for that investment, for that decision, because these are long-term investments. And what you'll see here at the bottom is just one vehicle that's been prioritized, but I assure you that it's a very long list. But what this is showing us is that 68,000 pounds of carbon have been emitted from that specific vehicle, but almost 2/3 of it are in disadvantaged communities. So as we're looking to maximize our value from our investments, that is the vehicle that we want to move forward with to maximize our decarbonization efforts while also reducing our impact in that specific community. Optimization modeling, a little bit different. This is run once a week because we're looking historically and understanding patterns in the data and patterns in our fleet movement across the service territory. So running this every single day isn't going to be materially new value for us. So when we do run it once a week, it is a very extensive SageMaker Lambda batch process that goes through every single vehicle to understand how much is it emitting and where is it emitting that. All of those insights are pushed out to Redshift, which are then, again, able to be consumed through the front end. And moving beyond fleet decarbonization, these are the 4 pillars that we're prioritizing, that we're bringing into the community impact platform, again, to optimize the value from our decision-making processes: facilities decarbonization, carbon intensity, carbon footprint. So as we continue to make investments in those areas, making sure that we have the right context and the community context to keep the communities front and center. Electrification, this can be electrifying our own fleet, but it could also be electrifying the transportation sector in California, which is a huge topic. As an infrastructure company, we have the ability to make investments to modernize the grid or increase capacity and recommend where charging infrastructure might be able to go to enable clean transportation corridors and clean transportation hubs to ensure that regardless of where you live and socioeconomic status, you can participate in the electrification of the transportation sector. From a reliability perspective, where should we be placing our microgrids to increase reliability? Where should we be investing from an infrastructure perspective or increasing our capacity to make sure that we're increasing reliability equity across our service territory? And ultimately, with climate adaptation, knowing that we're going to continue to see more and more climate risks and having the confidence in the context to make the right decisions is going to be key. So to go through a few quick examples for you to kind of drive the point home, I have community relations data. This is our giving data. Simple analytics can tell us how much we're spending, where is it going, how is it being used. But optimization modeling can tell us where we should spend our next dollar to increase equity across all of our communities, based off of those factors that we care about. Circuit reliability, this is our outage data. Simple analytics can tell us if certain communities are being impacted more so than others over and over again. Optimization modeling can prescribe or recommend an investment in a certain area to increase, again, reliability equity. Back to clean transportation, EV charging infrastructure. Simple analytics can tell us where there are chargers across the service territory, and what I will tell you is there is a strong concentration in and around affluent neighborhoods. But optimization modeling can help us prescribe or recommend where that next charger could go to increase equitable access. Again, regardless of where you live, regardless of your socioeconomic status, you should be able to participate not only in the electrification of the transportation sector, but participate in the energy transition in the way that you want to, which might be by buying an EV. And as we continue to mature the community impact platform and quantify the value, more and more we're looking to the system value framework, which was created by the World Economic Forum, which takes 12 different factors into account when prioritizing or investing in decarbonization projects. We talked a little bit about it with fleet decarbonization, reducing greenhouse gas emissions, increasing air quality. We talked about reliability, equity. And we also talked about equitable access. And over the next 5 to 10 years, as we continue to invest in this platform, we want to ensure that we can maximize system value with all of these topics into consideration, because this is all about doing right. And doing right in this context is enabling a fair and just and equitable energy transition for every single one of our communities. And with that, I'd like to thank you for joining me here today, and I'm going to invite Maggie back up on the stage.
Thank you. That was great. Great. Thank you, Gabe. That was fantastic. So in this discussion, we've illustrated the 3 Ds in action here. And I'm sure many of you are prioritizing your decarbonization and sustainability efforts and facing the necessity of change. That change of being a better and different business and community partner. San Diego Gas and Electric applies many of those methods to support their innovative approach, including that two-way door, a concept within their learn, prove, scale approach. They're building on AWS technology to affect change for the community, for equity, and for system value. So we greatly appreciate y'all joining us today. We're going to stick around a little bit for questions and even just to continue the conversation if you'd like to. So please feel free to come up and join us. We'll be just down at the end of the stage. Thank you again for joining us today.